Hello students and welcome back to our video classes. And this is the fourth consecutive videos of language of chemistry. I think you know me, I am Anik, your chemistry teacher. And today we are going to start with the ions. I think you remember how we, went through this chapter. First, we were going through the formation of this atom. After that, we were discussing about the different type of theories, right? I think you have watched all of those videos. Otherwise, you would not be able to understand what am I going to teach today. Fine. So you need to go through all of them. Okay. And only then you would be able to understand all of it. Okay. And you know what you have to do if you just want to share your doubts with us? You just have to write it on our forum. Fine. Now, the thing is, today we are going to start with the ions. So today we are going to learn what are the ions, okay, how they are getting formed and all these things about them. Fine. And after that we are going to learn about what are the different types of ions. Those are two types, cations and anions. And I know you get sometimes, you get confused with that. I know that. And I have a very cool way to make you remember about all of these things. Writing chemical formula, why we need them, chemical formulas, what are the uses of this chemical formula. Apart from that, how to form a new compounds if they give you the formula. Okay, if they give you the name. Okay. Now, apart from that, chemical equations, what are the reasons of these chemical equations? And definitely we are going to end this class with some FAQs. And I guess we are going to have a very good time with each other. Okay. Now, let's see. The first thing today we are going to start with, what are the ions? Okay. Now, first, I think you know that the atoms, there is inside the atom, if you've gone through the previous videos, you know that inside the atom, there is a nucleus, which is positively charged. Why is nucleus positively charged? Can you tell me, pause this video for a moment and try to tell me why the nucleus is positively charged? I think you have got it. Because all the protons, all the protons of the atom is there inside the nucleus. Fine, I think you got it. Now, what are the different types of subatomic particles? You remember I just taught you that we call them subatomic particle, right? Because they are inside the atoms, right? Subatomic particles. Now, protons, and what are there? There are neutrons as well, right? We haven't discussed about neutrons earlier. Look, neutrons was the most recent subatomic particle which was found. Okay, discovered, I should rather say. So it was done in 1936. Okay, and the protons and the others, they were discovered back in 1897, 1911, in those days. Okay, so neutrons are the, like, after that, after the formation of protons by Goldstein. Okay, we James Chadwick came and he just gave us the idea about the neutrons. So after that, we know that the neutrons and protons both are there inside the nucleus. We call it the nucleus. Fine. This was the last thing that we have learned in the last class. Now, today we are going to start with the ions and the different types of ions. So the first thing about it is, what are the ions? What do you mean by these ions? So what are the ions actually? Now, if you try to think, inside the atom, there are protons and neutrons inside the nucleus. And there are electrons revolving around this, right? There are electrons all around it, right? In different shells, in different orbits. And they have a particular number of electrons that can be held by a particular orbit. Remember all of them? We have read it in Bohr theory, right? So right now I am not maintaining any of it. I'm just trying to draw a particular diagram, because you can see in the first orbit I am placing 4 electrons, which is not possible, right? How many electrons can be fitted in the first orbit? Remember, 2 electrons in the K shell, right? It was stated by Bohr. 2 electrons in the K shell. If you don't know it, then please go through it first. 2 electrons in the K shell. Okay. And in the L shell, there are 8 electrons, right? Right. Remember it? In the M shell, there are 18 electrons. This is the maximum number of electrons that can be held by those cell. It doesn't mean that there are 18 electrons inside that. This is the maximum number, right? In the last class, we have read about it. If they ask you to grab, to take the chocolate from a bag, you would grab the maximum number of chocolate that your hand can hold, right? Isn't it? So that is the same thing here as well. An orbit can hold up to 18 electron or 8 electron or 2 electron. This is the maximum number. Among them, what is the number they are going to take? It depends on the number of electrons the atom has. Getting my point? If the atom have 4 electrons, it is going to get distributed in the different types of shell in such a way that every one of them are becoming stable. Everyone can hold that much electrons. If you don't remembering any of it, then please go through the last video. Okay, lecture number 3 of this chapter. Okay, you'd be able to understand everything in that. Now, coming back to the ions. Now, what are the ions? Ions are formed when there is a what should I say? There is a imbalance. There is an imbalance. There is an imbalance between the positive charges and the negative charges inside the atom. So when there is an imbalance between the positive charges and the negative charges inside the atom, only then we can say that there is an ion is getting formed. Now, how can this imbalance get generated? There are 2 ways. Okay, first think about it. What are the subatomic particles that is carrying some charges? Definitely protons are positively charged. Electrons here, they are negatively charged. Neutrons are neutral, isn't it? So the imbalance is when I am saying there is an imbalance between the positive and the negative charge, then what I mean to say is there is an imbalance between the proton and the neutron, proton and the electron, isn't it? Isn't it? Protons and the electrons, the number of protons and the number of electrons are different because in a shell, in an atom, the number of proton and the number of electrons are always equal. To make it neutral, right? So to make it neutral, all the atoms are neutral. Number of protons, you know it, right? Number of protons are always equal to the number of electrons, isn't it? The number of protons and the number of electrons. To make the entire shell, to make the entire atom neutral, the number of protons and the number of electrons are always same. Okay, got it until now? No. Okay, fine. So now when can an ion get formed? When can an ion get generated? When the number of protons and the number of electrons are not equal, only then an ion can get generated. Okay, so when the number of protons are more than the number of electrons, when the number of protons are more than the number of electrons, then in this case, tell me what would be the charge of this atom? Think about it. Protons are positively charged. Okay, new electrons are negatively charged. Fine. When the number of protons are more than the number of electrons, what can be the charge of the atom? It should be negative, isn't it? It should be positive, right? So it would be positive, right? Not negative. Don't nod with me. Okay, so it would be positive. So it would be positive, and such ions are called the cations. Such ions are called the cations. When the now we are just coming to the next possibility. Okay, what is the next possibility? When the number of, you tell me, electrons are greater than the number of protons. So there is another possibility when the number of electrons are more than the number of protons. Definitely in this case, the charge of the atom is going to be negative, isn't it? It's going to be negative. I think you got it so far. So if this is negative, the overall atom is now not an atom. This is not an atom anymore, right? When there is a charge in an atom, this is not an atom anymore. We are going to call it ions. So when it is negatively charged, we call it anions. We call it anions. Now, how to remember that? Which one is cation and which one is anion? How to remember that? Just remember one thing. Just wait for a moment. Just remember one thing. Cations are positively charged. Cations are positively charged. So how to remember this? Just remember one thing. Cats have paws. Isn't it? Isn't it cool? Cats have paws. Wait for a moment. Yeah. So as the cats have paws, so cat stands for cation and paws stands for positive. Isn't it cool? So from here you'd be able to remember that the cations are positively charged and the anions are definitely going to be negatively charged. Done. I think you have understood it. So there are two types of ions so far. What we have learned is generally the nucleus is consisting of the positive charges only, but inside the atoms there are different types of charge. There are two types of charges. One is positive and another one is the negative one, right? The negative ones are called the electrons and the positive ones are called the protons. Neutrons are also there, but they are not charged, right? So number of protons and the number of electrons are going to be same because inside the entire atom is neutral in nature. Got it so far? And after that I told you, but if for some reason, if the number of protons is more than the number of electrons over here, you can see the overall charge of the atom is going to be positive. I think you got it so far. So we call it cations. So cats have paws. So from there, cations are positively charged. And when we are moving on to the next part, here you can see the number of electrons are greater than the number of protons. Okay, electrons are greater than the number of protons. Electrons are negatively charged. The overall charge of the atom is going to be negative. Let's take some examples. Let's just consider that you have an atom. I'm just going to write it. Just give me a moment. You have an atom that has 6 protons and 6 electrons. Tell me the name of the atom. Pause this video and try to tell me the name of the atom. This is very simple. I told you to remember, I told you to go through the name of the atoms up to 1 to 20, the atomic number. The atomic number 1 to 20. You need to remember this. Mnemonics, you have tons of mnemonics in the internet as well. You just use one of them and try to remember the names of the atom up to atomic number 20. Okay, it is necessary. Okay, fine. Now 6 protons and 6 electrons. Tell me the name of that atom. It is going to be oxygen, right? It's going to be oxygen, right? No, wrong. It is going to be carbon. Fine. So this is going to be carbon. Carbon has 6 protons and 6 electrons. Now tell me one thing. If by any means carbon takes up 1 electron, by any means, if it takes up 1 electron, what would be the charge of this carbon? Electron is negatively charged and it is taking only 1 electron. So it is taking 1 negative. So now the thing is, after taking up 1 electron, so after adding 1 electron, the thing is having right now 6 protons and 7 electrons, isn't it? Isn't it? Got it so far? Now let's try to draw this thing. 6 protons means 6 positive charge. 1, 2, 3, 4, 5, 6. 6 positive charges. 7 electrons means 1, 2, 3, 4, 5, 6, 7. Now 6 positive charges are going to eliminate 6 negative charges and going to make it neutral. But 1 electron, 1 negative charge is extra there. So for that reason, the charge of this carbon would be C minus. Okay, now we call it a cation, right? We call it an anion. Cats have paws, right? So we call it an anion. Now, similarly, if I just take out 1 electron from this compound, if I just write it again, 6 proton, I have 6 electrons with that, and I am taking out 1 electron. I am taking 1 electron. So what is the thing I'm going to get from here? I have now 6 protons plus 5 electrons. We are going to get 6 protons plus 5 electrons, isn't it? Now, draw it again. 6 protons, 1, 2, 3, 4, 5, 6. And 5 electrons, 1, 2, 3, 4, 5. Okay. Now, what is the thing going to happen? 6 protons are going to 5 protons are going to eliminate 5 electrons, and I have 1 positive charge extra, right? So for that reason, now this carbon is going to be C plus. Okay, this is going to be C minus, and this is going to be C plus. So this, as this was an anion, this is going to be a cation, isn't it? This is going to be a cation. Fine, fine. Got it so far? Okay, fine. Well done. So this was the entire thing about the cations and the anions. Now, definitely, you know what? You need to watch this video till the end because I have some good questions for you. Okay, like in the end of this video, I'm going to teach you why am I only considering the electrons. Like, have you noticed one thing? I have only said that if I am taking 1 electron or if I am adding 1 electron. I have never said if I am adding 1 proton or if I'm taking away 1 proton. So why am I not saying that? Okay, I'll come to that, but in the end of this video, you need to keep on watching this and you need to keep your head calm and fully concentrated on here. Okay, and if you have the answer, you just try to think about it. If you have the answer, let's see whether it matches with me or not. Okay, fine. Understood so far? Just give me a moment. I just need some more space over here. Just keep it down. So should I watch a video? Should we watch a video to make it better, to make our understanding better? Let's see. So this video over here is going to teach you again about the ions and make your concepts clear, more clear. Okay. What are the ions? This is the thing. Okay. Now let's see what are they showing. Remember this like this structure. Why they are showing this structure over here? This was, tell me, who was the inventor of this structure? Who was the one who just first told us the atom looks like this? Tell me. Niels Bohr? Ernest Rutherford, right? Ernest Rutherford. This is going to be the right answer, the Ernest Rutherford. The electrons are negatively charged. You know it already. Okay. So the charged particles are called ions. Now, when an atom is losing an electron, 2 electrons, we call that is getting positively charged. When it is losing electron, it is getting positively charged. Okay, and positively charged ions are called the cations. Okay, and they're going to show you the again the same thing, that the cats have paws, right? So cations are the positively charged. Now, when an atom is gaining electron, they are getting negatively charged. So there is a technical fault in this video. So they are showing you that it is gaining 2 electrons, and after that in here you can see they are giving 1 minus charge. This is wrong. If they are gaining 2 electrons, this is going to be 2 minus. If they are losing 2 electrons, it is going to be 2 plus. Fine. So negatively charged ions are called anions. So sodium, this is an example for you. So this is the, the entire structure of sodium with the proper configuration. You can see K shell is having only 2 electrons. L shell is having near about 2, 4, 6, and 8 electrons, which is its maximum capacity. And M shell is having only 1 electron, right? This is what we have studied earlier. So this is sodium. This is the electronic configuration of sodium. Do you remember this? Tell me, what is the atomic number of sodium? The atomic number of sodium is 11, isn't it? Let me draw. So atomic number of sodium is 11. So 11 means 11. Tell me, what is this? Is it the number of protons or the number of electrons? Tell me. This is atomic number, isn't it? This is atomic number. Atomic number. Atomic number stands for the number of, doesn't matter. It is the number of protons, but this is also the number of electrons as well, isn't it? Now, if it is 11, let's try to draw the structure, draw the configuration of electron. Okay, arrangement 2, 8, 1. So this is going to be the arrangement because 8 plus 2 is 10, and after that I'm adding 1 with it, so it's 11, right? Isn't it? So now this is going to be, this is the same structure they are showing you in this video, isn't it? No, it's just keep. So you can see it has 1 electrons, and that is they have a new word they are saying. Is it new to us? If you haven't watched the previous video, then it is going to be new to you. But otherwise, all of us know that we call it valence shell. The last shell of an atom is called the valence shell because it is going to show you valency. And now what is valency? That was also in our last class. Okay, so please watch that video first. After that, keep on watching this video. Otherwise, this is going to be so difficult for you to understand it. Okay, now here and now here, this is the valence shell, isn't it? This is the valence shell. This is the valence shell. Okay, there is another name of this valence shell. We can also call it ultimate shell. Okay, ultimate shell. And the shell which is just before the ultimate shell, yeah, so the shell which is just before the ultimate shell, we call it penultimate shell. Let me show you which one is the penultimate shell for sodium. I think you got it, right? Just wait for me. L shell over here is the penultimate shell. Okay, penultimate shell. So someone may ask you this question, what is the number of electrons present in the penultimate shell of sodium? So it would be 8, isn't it? It would be 8. Now, ultimate shell is the valence shell only, right? The valence shell and the ultimate shell are just the same, isn't it? Now let's just get back to the video now. So when we are taking out that electron from the valence shell, sodium is becoming Na plus, right? Sodium plus ion. So this is how it is written. You can see the cations are written like that. So earlier we used to write like Na, but when it is a positive charge ion, we are going to write it Na plus, okay, over its head. And if it was negatively charged, then we would have writing like Na minus, correct? So you can write it like that as well. When you are writing the electronic configuration, you can write it like that as well when you are drawing it. So after drawing it, you just enclose it in a parenthesis, like a third bracket, and just in the top of that, just write plus or minus, whatever it is, right? So now the second example is oxygen. So again, the electronic, so before watching this, tell me, what is the electronic configuration of oxygen before watching this? Tell me. What is the atomic number of oxygen? What is the atomic number of oxygen? So if it is oxygen, the atomic number of oxygen is going to be 10, right? 8. 8 is the atomic number of oxygen, right? Now, if 8 is the atomic number of oxygen, tell me what can be the electronic configuration. So let's write it. What's happening? Yeah. So electronic configuration. Electronic configuration of oxygen is going to be K, L, M, N, and after that 8. Okay, 2 and 6. So this is going to be the electronic configuration of oxygen. Now if I ask you what is the valence shell, the number of electrons in the valence shell of oxygen, how many electrons are there in the valence shell of oxygen, you are going to tell me that in the valence shell there are only there are only 6 electrons, isn't it? So this is also the valence shell of oxygen. But if I ask you what is the valency of oxygen, what would be your answer? So if you have watched this video, previous video, your answer is going to be 2, isn't it? 2 is the valence. Clear? This is going to be the valence of oxygen. Okay, I think we are all in the same page, isn't it? Let's see. 2 and 6. You can see the diagram, 2 and 6. Now there are 6 electrons in the valence shell. You can see that, and if it takes up 2 electrons, so you can see right now over here, I told you, right, this is going to be 2 minus, and you can see there are 2 minus are getting formed. Okay, 2 minus charge. So this is also ion. So this is how you are going to write the symbol, and this is how you're going to write the electronic configuration. Got it? Now, I think that is enough. I think that is enough. So the thing is, this is how you can understand the thing which is ion is, what ion is. Okay. Now, if I ask you, if I just go to the next part, I think we have all understood all of it. What is an ion? What is the cations? What are the anions, and how they are getting formed, right? So we have completed this part. Fine. Now we are going to write, understand how to write a chemical formula. Okay. So before that, before writing a chemical formula, we need to know the valencies of each and every atom. Okay. So do you remember the valencies of every atom? Let's just make a quick revision. So if I ask you, what is the valency of hydrogen? Tell me, quick, be quick. 1, right? What is the valency of helium? Tell me, be fast, 2, right? No, it's 0. Fine. Now, if I ask you what is the valency of carbon, tell me. 4. Very good. I think you got it, right? Now, tell me what is the valency of, let's see, magnesium. Remember? Tell me, atomic number of magnesium is 12. So the valency of magnesium is 2, isn't it? I think you got it. Now, if I ask you what is the valency of aluminium, let's see who can tell me. It would be 3, right? Because aluminium is 13. Okay, so this is how you are going to do this. So you need to understand that you need to go through all these valencies and all these atomic numbers. This is very much important. So the last video was very important. You should go through it. Only then you would be able to understand all of it. Okay, so you need to know the valencies before you come to this section. So if you still don't know the valencies, please go and watch the previous video. Now, if you know the valencies, then welcome. And one more thing, let's understand what is the valence of chlorine. Let's say chlorine is has a valency of 5. 1, isn't it? Some of you are saying that this can be a plus or minus in that. Yeah, we can give that as well. So yeah, there will be +1, there will be a +4 or -4. So for carbon, there is something special. I'm not going to discuss about that right now in this video, but definitely we would learn that. And there was magnesium. Maybe we can write it +2, and aluminium +3, and for chlorine it should be -1. But we don't care, right? We know it. So plus and minus is showing you whether it is donating the electrons or it is accepting the electrons. But we know it, and we should, it's all about whether you know it or not. You can write it like that as well. You can write it like this as well, like the plus without the plus and minus. That doesn't matter. But now, if you know about them, then we are going to learn today how you are going to write a formula. How are you going to write a formula? Fine, let's see. Now, to write a formula, what you need to remember is the valencies first. Now, if I am trying to write a formula made up of, so let's just try to draw a formula of sodium chloride. Sodium chloride. So what can be the formula of sodium chloride? How to write that? How to understand that? How to write a chemical formula? So there are a few steps. Just remember one thing. For the inorganic compounds, inorganic compounds, the sodium is, so the cations are written first and the anions are written after the cations. Okay, so first we are going to write symbol of the cation. I'm just writing it all. Symbol of the cation, and then we are going to write a symbol of the of them. Now after that you need to write the valency of the cation as well as the valency of the anion as well. If you know all these three things, you'd be able to find the chemical formula very easily. Got my point? Okay, now how to find out that? So the thing is, what is the valency? Let's just go through the exact example we have. Let's go through it only. So just tell me, sodium chloride again. Okay, this was the question. Sodium chloride. So tell me, what is the symbol of sodium? This is the cation, right? This is the cation. So what is the sodium symbol? So Na, and how we write the cations? Plus in the over it, right? You can either write a circle over here, or you cannot. Like, it's up to you what you want to do. And the chlorides are, so I'm just going to, so forget about it. Forget about the charges. So first sodium and the chloride. Chloride is something which is coming from chlorine only. I think you can get it. This coming from chlorine only, right? Now, we are going to write the valencies of both of them. So sodium valency is 1, and the valency of chlorine is also 1, isn't it? Now, to write the structure of sodium chloride, what you have to do is the last step. The last step is, in the last step, you are going to just make a crossover. So you are going to write the valency of sodium with chlorine, and you're going to write the valency of chlorine with sodium. This is what you're going to do. Okay, and we call it crossing over. You can see there are so many, in the picture there are so many things in like crossed over products, right? So crossing over. Okay, so when you are just doing this, you'd be able to find the formula. So what is the formula coming out? Na1 Cl1. Remember one thing, I'm not going to write anything in that. So this is how you can write the chemical formula. Let's just go into some other examples as well. Like you can see over here, it is just trying to write the formula of potassium chloride. Okay, so potassium Okay, potassium chloride. Now you can see the potassium is having one valency of 1. So let's just do this. Potassium chloride. Fine. So what would be the formula of potassium chloride? Think about it. Just try to do this. Come back to you in a moment. Potassium. What is the formula of potassium chloride? So potassium means K. Chloride is coming from chlorine, so it would be Cl. Okay. Potassium. Okay, potassium has a valency of 1. Chlorine has the valency of 1 as well. Again, the formula would be KCl, right? Isn't it? We are getting it right. The formula would be KCl. So this is how you can write the formulas. So if someone asks you what is the formula, so if someone asks you what is the formula of, let me think. What is the formula of aluminium chloride? If someone asks you this question, aluminium chloride. So what is the formula of aluminium chloride? So first, aluminium. First is aluminium. Next one is chloride. Correct? Correct. So the valency of aluminium, it is 3, right? And the chloride would be 1 again. Okay. So from there we can write the formula by crossing it over, like aluminium with 1 and chloride with 3. So it would be coming like AlCl3. Got my point? It would be AlCl3. So that is how you can draw different type of structures. You can see in this chart there are so many structures, okay, for you to practice them. Okay, we are going to learn about some few cool things after that. Okay, I'm going to tell you, like, this is not the entire valency thing. Okay, there are so many things to learn about valency. I'm going to teach you that in the end of this video. So right now you can take a 5-minute break. Okay, like you can do that. After that, come back to the session again. Okay, I'm just giving you a 5-minute break if you want to take it, and if you just want to continue it, just don't pause this video. I'll just continue from here after. Okay, fine. So I think you got your break, and we are going to continue with the next part. So let's see. This is why we left this video, and this is the different types of valencies you can see of different types of cations and different types of anions, and we are just merging them together via crossing them over. This is how we are going to find the valencies and find the different types of formulas. Fine. So if someone asks you, after all these conversations, if someone asks you, let's just do it backwards. Okay, they said do it completely backward. If someone gives you a question like this, someone gives you the question like this, I have a formula which is like ALN. I have this formula. Okay, it's not supposed to come now. If I have this formula ALN, tell me what is the valencies of Al and N? How would you be able to do that? Now, to solve this question, what you have to understand is you need to know the electronic configuration of aluminium. So let's just do it from the scratch. KLM and N. Okay, and now we have aluminium, which is 13. Aluminium is 13, right? So 2, 8, and 3. Now from here, can we say the valency of aluminium is 3 only? Right? Because it would lose 3 electrons, right? It would lose 3 electrons. It would lose 3 electrons. So sorry, only one O. Okay, it would lose 3 electrons. Now, so the valency is 3, isn't it? if the valency of aluminium is 3, can you tell me where is it written? Where is the 3 letter written? You cannot see it. You cannot see it, but actually it is written. So I'm just writing the valency of 3. It is written just beside nitrogen like this. Why you cannot see it? Now let's try to understand this as well. So if nitrogen has the valency 3, I'm just considering if it has a valency 3, then what can happen? Then aluminium and nitrogen both would be written like this, Al3 and 3. Now when both of them are having the same valency, it would be nothing but Aln, isn't it? When they have valency 1 on then, and when they have the same valency, we just write them like that. Okay, we are not going to write any numbers in there. Okay, so the valency of nitrogen and aluminium is 3. We can understand while looking at it. Otherwise, if you just want to clarify whether the valency of nitrogen is 3 or not, what you have to do is you just have to write it like here, and KLMN like that only. Nitrogen has the atomic number 7, 2, 5. So here there are 5 electrons. It wants to take 3 electrons so that it becomes 8 like the inert gases. Now, in order to do that, you can say that the valency, this is going to be the valency, isn't it? This is going to be the valency of what? Of nitrogen. Fine. So this is how we can cross check it, whatever we have done so far. This is how we can cross check it. Clear? Clear, everything? Clear? Okay. Now I'm just going to watch a video on chemical equations. But before that, as we know that how to draw different types of ions, different types of anions and different types of cations, and how to draw the different types of compounds, or which should rather say how to draw their formulas. So that's how we can make different types of formulas, and we have to use that. Okay, now we have to use that. So where are we going to use it? Okay. So the chemical equations. So this is where we are going to use it. Now, before coming into the chemical equations, we need to understand why do we need these chemical equations on the first place. So let's just think about it. Let's just think about it. This is a serious problem. Okay, let me tell you, a very serious problem. So I'm just trying to track this thing. Okay, give me a moment. Okay, just trying to put this thing over here like that. It would be look complete, right? Put it over here. Yeah, just like that. Yeah, so this was the thing. Now you can see here. So now we are going to see what is a chemical equation. First, we are going to learn what is the need of this chemical equation and what was the problem with the so far whatever we have right now in our hand. What was the problem with that? Why do we need this new thing at all? So the first thing is chemical equation. Okay. Now, what is the speciality about it? Think about it. If I just try to tell you that like an equation like this, if I have magnesium, or if I just take let's just go through a particular reaction. Okay, so if I just tell you that like this, I have magnesium, and if I like that react it with oxygen, I am going to get okay, like this: magnesium. I'm going to get magnesium oxide. So if I just write the entire thing like this, what can be the problem? The problem is like this is going to take a lot of time. And apart from that, the person who doesn't understand English, this is not going to be, of any use of him. So we need to think about something else. So the first thing is, if I just write the entire reaction like this, like we call it word equation. If I write the entire equation like this, like magnesium plus oxygen gives us magnesium oxide. So is it, is it making any change? Think about it. It is just, decreasing the time. That is also of a very good use, right? Previously, it was taking a lot of time, but right now when I'm writing the word equation, it is taking less time. So when I am writing the things in the left side, all the things those are written in the left side, they are called the reactants, because they are the one who is going to get reacted. They are called the reactants. And when this is written on the right side, we call it the products, right? You know it. For a moment. Yeah, we call it the products. Fine. These are the reactants and these are the products. Now, this is also, making the same problem. So there is same problems again over here. Though the person who doesn't understand English, he would not be able to understand it, right? So we need another modification. So now we are going to understand. Now we are going to introduce the chemical equations over here. Now, how to write the chemical equations? So for chemical equations, we need to know the symbols. That is why we have understood how to write the formulas first. Okay, now we are going to write the chemical equation. So it goes on like this. Magnesium, we know the symbol of magnesium, and we know the symbol of oxygen. So magnesium is reacting with oxygen. This goes like that to give us magnesium oxide. Now you tell me what would be the formula of magnesium oxide. Magnesium oxide, okay, let's do it here. Magnesium oxide, right? Or let's do it here. Magnesium is having the formula of Mg. Oxide, it's coming from oxygen. Valence of oxygen 2, valence of magnesium 2. So magnesium oxide would be MgO. So crossing over, 2 crossing over. After that, as they are both the same, so for that reason they will be giving you MgO. Got it? So now magnesium, why magnesium is 2? I think you know it now. Magnesium is 12, oxygen is 8. Now I just put it over there, you'll be able to understand why I am writing 12, why I'm writing 2 as the valency. Okay, you need to keep on practicing the valency part. Okay, this is going to make this is going to be a very difficult part for you if you don't know it, if you don't practice it that much. So this is the magnesium oxide. So this is how chemical equations are written. So you need to know the formulas, you need to know the symbols and the valencies to write a chemical equation. But once you write it, throughout the world we call it the chemical equation for the formation. So throughout the world there is no one who doesn't know the formulas of magnesium and oxygen and all these things. Okay, if I'm just writing the formulas, they are going to understand each and every one of it. Okay, now we'll watch another video to understand the entire thing. What is the chemical equation? What is the use of this chemical equation? Fine, let's see it. Okay, just taking a little bit time. Are you getting my points? I think you have understood all these things we have gone through. You're understanding it? If you have any doubt, you are going to write it on the forum, okay? And we will definitely get back to you. And are you practicing the homeworks? Okay, I think go through the classes. Okay, don't skip your classes. Although if you have this video along with the classes, then definitely it is going to be the best thing for you. Keep on going to your classes, take your the homeworks they're giving you. Okay, this video would definitely be helpful for you if you just watch till the end, because I'm going to give you some very interesting tips over here. Okay, now so you can see over here the beginning. In the beginning only, you have seen that there is a chemical equation like CO2 and all these things. You can see over here as well. They're writing so many things. They're writing so many equations, and you can see there are so many formulas over here: NaCl, NaOH, HCl, H2O. So I think if you just try to think about all of them, you'd be able to understand. Okay, so this is how the formulas are being made, and this is how a chemical equation is being written. Okay. So this is the change of chemical reactants into the products, right? Okay. So as I told you, the left side, all the things those are written are the reactants, and the right side are the products. So there are so many things. This is, you can see, like in the over here, this is the word equation, and the above that, this is the chemical equation. Okay. And this arrow is showing you that the reaction is going in which direction. Okay. Like a one-way street, it is just showing you the direction of that street. Similarly, this arrow is showing you the direction of the reaction. So this is the reward equation from where you can understand that sodium hydroxide and hydrochloric acid are reacting with each other to give you sodium chloride and water. These reactions are called the neutralization reaction. Why do we call it? Do you know that? Because sodium hydroxide is a base. Hydrochloric acid is an acid. You can see it over here. When an acid and a base reacts, they give you the products, which is a salt and water. These type of reactions are known as neutralization reactions. Okay, I think you can understand the arrows are pointed towards like left to right. From there, I think you can understand the left side ones are the reactant and the right side ones are the products. So this is the word equation, just describing it, like which one is more easier and all, because this is not easier. The previous one was the easier one, right? Reactants on the left, products on the right, right? So this is going to be very simple for you to understand when you know the equation, how to write them and all. So this is what they're trying to tell you. A symbol equation always gives you more and more informations, while the word equations gives you more, more about the reaction, like a summary of the reaction. But the symbol equations, they are going to give you the entire idea of the reaction. So again, the neutralization equation, they're just going to show you the neutralization reaction again. NaOH plus HCl. Okay, there is something new over here, right? Can you see it? Like there is an S and there is an AQ. What does it mean? S means it is solid. Okay, and AQ means it is aqueous. AQ means it is aqueous. Okay, there is water in it. It's a like right direction. There's a right direction over here, and NaCl and the H2. So you can see aqueous again. Aqueous means it is the like dissolved in water. And liquid means liquid. And what is the difference between liquid and aqueous? Aqueous means it is dissolved in water. Liquid means it is just melted. If you just take something and if you just melt it, it would be liquid, right? When you take some ice and you just melt it, it would be water. That is the melting. And what about the aqueous? When you dissolve it in water, okay, that is aqueous. Got my point? So these are the states of the reactants and the products, right? So I think that is enough for you to understand how to what is the present, what is the importance of the chemical equations, all of this. So if you just go through the PPTs again, so here I think we have covered all the things about the ions, the cations, the anions, the formula, and the chemical equation. We are not finished yet. So ions, you can see there are the cations, there are the anions. So you can see the cations are the ions with less number of electrons, anions are the ions with more number of electrons, right? Now, here you can see these are the cations. Cations are more positive charged. Okay, so for that reason we call it cations. Cats have pause, right? And now after that, anions, you can see that anions are the ions that have more negative charges. Okay, and there you go. So you can see crisscross method of formula writing. You can see it over here. There is a formula written like Ca2 plus N3 minus. So how to understand that? I think calcium is 20. 20 means 2882. You're getting me? 2882 KLMN shell 20 2882. Last shell, valence shell contains, or ultimate shell contains 2 electrons. So the it would give up that 2 electron to become 288. Okay, I'm just dictating it, you just do it on your copy. It would become 288. It is just losing 2 electrons. Its valence is 2, nitrogen's valence is 3. Now you write what would be the formula of this calcium and nitrogen compound. Isn't it coming Ca3N2, right? Nitrogen 3, it is right written below calcium, Ca3N2, right? So this is how you are going to do it. Fine. And this is the word equation where I have already told you the left ones are the reactants, the right ones are the products. One more thing, there's 2 over here, we call it coefficient. This 2 over here as well, we call it coefficient. Sometimes we call it stoichiometry. 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 Stoichiometry, we call it. Okay. Or you can call it coefficient as well. Both of them are the same. Okay, fine. Now there is a simple question. What are the 4 symbols used to denote physical state in these equations? So in this equation, what are, so sorry. In this equation, so that's like I have to give you the equation over here that is not written already. So what are the 4 symbols used to denote the physical states in this equation? So if I just don't give you the equation as well, would you be able to tell me what are the symbols through which you can denote a physical state of the equation? So you can do it, right? You can do it. So let's try it. See, without the equation as well, you could be able to do that. So now the first thing is what you have to do. Wait for a moment. Yeah. Okay, so something is wrong with that. Let's forget about it. So if I just shut it down and if I just tell you what are the 4 possible states of matter, states that you can write to describe a chemical equation. So let's see. So symbols to describe the states let's see, the states of a what, of a reactant or a product. So how to describe the state of a reactant or a product? How would you be able to do that? So there are 4 ways through which you can describe this thing. Okay, check. So the first is when the reactant is solid. When it is solid, we give the symbol S. When the reactant is in liquid form, we give them the symbol L. When the reactant is gaseous in nature, we write G over here. So this is how you can write the different symbols of three different states. And there is another state, I think you have seen it, aqueous, AQUEOUS. I think you have already seen it, aqueous. So we just write it like AQ. Fine. So it is written like AQ. So these are the states, different type of states, of different types of textures of this chemical equation that we generally use to describe the position, describe the state of the reactants and the products. Fine. Now coming to the question. So let's just come to the question. The question was, so for a moment. The question was, why are we only taking out or giving the electrons? Why aren't we talking about the protons? Look, let's see whether it's matching with your answer or not. So protons are there in where? In the nucleus. In the nucleus. Okay. Nucleus is the center of attraction. Okay. This is the center of attraction, isn't it? This is the center of attraction. So now you cannot touch a proton. Okay. Only nuclear reactions, nuclear reactions involves protons. Okay, only the protons. Fine. Action what we are learning right now. For you cannot, you no, the video is lagging a little. I think my voice is coming clear. I don't know. You see? Yeah, the video is lagging a little. Okay. So the thing is, we are just came to the last part of the thing. So nuclear reactions involve protons. Okay. So you cannot touch the protons. Okay. So what you can do is you can play with the electrons. So you can play with the electrons only. You cannot touch the protons. Fine. So you can give electrons or you can take away electrons from a particular place, from a particular shell, from a particular orbit, or from a particular atom. You can do that. But first, if you give some energy, it would take up the valence electron only, because those electrons are living far away from the nucleus. So that is why we can only understand that we are going to take only the valence electrons only. Okay, fine. So for that reason, we cannot use this thing, these protons and all. And what else? What else can we say about this? Last thing. Okay, this is the last part. So just remember one thing: the anions, they have some names. So if I just try to categorize them, anions are mainly having three types of names. One is ide, another is ite, and another is ate. So there are mainly three types of name that comes with the anions. Chloride, bromide, iodide, all these things are containing these names. Okay. Just remember one thing. This is a trick. As I told you, I'm going to show you a trick. So just remember this thing. Okay. Whenever you see this word ide, just remember this stands for no oxygen. So when the anion is having no oxygen in it, we call it ide. Fine. Think about it. Chloride is Cl minus. Bromide is Br. Iodide is I minus. Like cyanide, Cn minus. Okay. There is only one exception in this rule.